between elements in a compound, give me some examples of things that I can put up here that we've studied that are composition stoichiometry that'll be on the next test or that are on the benchmark Tuesday. Formula mass work. Okay, formula mass is a type of composition stoichiometry. Something else. Percent composition is a type of composition stoichiometry. Two more I want. Molecular mass is the same as formula mass. Empirical formula. There you go. Empirical formulas and molecular formulas. All right, those are the major ones. Now, we could also talk about grams to mole. When we converted to grams to mole, those would also be types of composition stoichiometry. Okay, all of those things that we did are examples of composition stoichiometry. So when we take the next test, even though some of this has already appeared on a test, it will also be on the next test. Okay, things like empirical formula, molecular formula, and percent composition haven't been on a test yet. They'll be on the benchmark, but they haven't been on an actual test. That will also be on the next test. Now, the new stoichiometry we're going to do, all right, it's called reaction stoichiometry. It's going to deal with mass relationships between compounds in a balanced chemical reaction. Now, I have been referring to this for a couple weeks now. We've been talking about the fact that moles always had what number in it in a chart? Always had 1. Until we were able to balance the chemical equation. Well, guess what? We can balance the chemical equation now. So now we can talk about math where the moles are not always going to be what? 1. We can talk about how we can change the moles into different numbers. So today we're going to start talking about reaction stoichiometry. We're going to learn 4 new problems. There are others I can teach, but for the sake of the curriculum, and there are other things I will add in other places. There are other things I've already added in. And unfortunately, our time is limited together, so I have to chop in places. So limiting reactants is not one I'm going to teach. It is one of the places I have elected to cut. So we're only going to do 4 types of stoichiometry problems, and then we're going to move out of the math. So for those of you who've been praying for the end of the math, 4 problems, test, and we're out of the math for a while.
I prefer this over the
Okay. Well, the balancing is going to stay with us for these 4 types of problems. But once we leave this and we go to quantum theory for about 3 or 4 days, some of y'all are going to think I have really lost my mind. It's going to start to begin to talk about where the electrons are located in and out.
The electrons?
The concentration, way at the end of the semester. I mean, like right before the exam. All right, so reaction stoichiometry is going to talk about, for example, how to change grams of chlorine to grams of Na. Or maybe like today, we're going to have moles of Sb, and we're going to change it into moles of F2. Okay? We're going to change from one compound. All right, you notice that was one compound. We changed it into a different compound. So in both of those examples that I put there, notice that I changed compounds. In order to change compounds, we will have to have a balanced equation. We can't. Huh? Well, it doesn't really matter. I just call them generically compounds. Down the road, because we'll have things that are neutral and things that are ions, I'll call them generically. All right, are we caught up? Now, in order to do this, we only need one new skill. Okay? One new skill is all we need. The new skill we need is this. We need to learn how to write a mole ratio. Once we've learned to write a mole ratio, this will take us about 5 to 10 minutes. And once we have, we only need to learn how to work a word problem. Okay? SV, moles of F2. All right, so a mole ratio is our only new skill today. Writing a mole ratio. Moles of F2. Yep. So, what is a mole ratio? A mole ratio is a conversion factor. That is its function. It's a conversion factor that allows us to change from one compound to another. All right, it allows us to change from one compound to another. Right? Now, if I'm telling you that it allows us to change from one compound to another, if reaction stoichiometry is about changing from one compound to another, should we work any problems in this unit that don't have a mole ratio? No. And some of you are going to hand me a chart without a mole ratio in it. So what do you know is going to be wrong? All of it. Okay? Which means you lose massive points if you don't have a mole ratio. So when you're working your problem, before you turn it into me, you need to make sure there's a mole ratio. If there's not a mole ratio, you should know that something's wrong. Every problem has to have a mole ratio. That's the basis for which we do these questions. Without it, you didn't change compounds. Now, here's an easy reaction. Everybody can balance it. Not difficult. If you can't, we're some sort of chip. And I'll be suicidal by the time I finish straight.
Wait.
Why don't y'all just balance it first on your paper? And then we'll feel more confident. You can call it part 3. We did know the easy gram mole atoms, and then we did the empirical formula stuff. Now we're doing this. This is really our third foray. Start count. Like that work? Y'all?
Yeah.
My daughter at West Davis. She comes home some days and I'm like, where did you come today?
Right here. I was. Emma, I do not need her.
When their dress up day for homecoming was on Wednesday? America Day. Okay, they wore a, they didn't have America Day, they had America Day. Like, really? Did y'all sound a little more redneck?
Well, I saw stuff like rough.
Last year I almost told Ricardo to pick him up to homecoming games because I almost ran over a tractor. All right. So, if we look at the equation, everybody came up with what number? 4, 3, and 2, right? Everybody could do this, correct? Now, the nice thing about these numbers, these coefficients, is they tell us the number of moles. So how many moles does iron have?
4.
Good.
Oh.
How many moles of oxygen are there? 3. Now, sometimes people try to tell me they're how many? 6, because they try to multiply the moles by saying the coefficient of 3 and the subscript of 2, but it doesn't work that way. The coefficient are the moles. So how many moles of iron trioxide are there? 2. All you have to remember is the moles come from the coefficient. That coefficient's got a little mushed up there because I ran out of space. Okay? But the moles come from the coefficient. Now, mole ratios are just based on the coefficient. Now, we're going to figure out mole ratios from the word problem. However, writing a mole ratio is just based on picking a reactant or product and putting one over the other. So if I call Jordan and I say, give me one of those items out of the reaction, which one do you want? Okay, how many moles of oxygen are there? Okay, so we would write 3 moles of oxygen over, Queen, give me something you like other than oxygen out of the reaction. Okay, how many moles of iron are there? 4 moles of iron. That is a mole ratio. Okay, Priscilla, give me something you like out of the reaction. Any of the 3. Okay, 2 moles of Fe2O3 over something you like, Catherine. 3 what? 3 moles of O2. That is another mole ratio. All right, let's do one more. All right, David, give me something you like out of the equation. I don't care what. Okay, 4 moles of Fe. All right, Victoria, give me something you like out of the reaction. Just don't take Fe because David already did. All right, over 3 moles of oxygen. Okay, all of those are mole ratios. Okay, questions about how we wrote a mole ratio? Now, I have coefficients that come from the equation. I included the units, which are moles. I included the compound name. Questions about how I did that? Everybody feel okay about that? It doesn't make any difference at the moment. It's arbitrary because we have no problem to solve from. We're just writing a mole ratio. Now, what if I said, find the mole ratio of the reactant? Who could you not pick if I said, write a mole ratio using the reactant? That's right. I couldn't pick that one. I can only pick these 2. But if I don't limit you and I just say, write a mole ratio, you could pick from either side.
Oh, so it doesn't do that?
But in a minute, we're going to do a word problem, okay? And then I'll narrow it down for you so you know who you've got to start with and who you've got to finish with. Okay, but we haven't done a word problem yet. Say what again? So, for example, let's say I have this. And I said, like here, write 3 mole ratios. Did I limit you on what side of the reaction you can use, please? No, you can pick any of the 4 compounds. But what if I said only use the reactants? Write a mole ratio using the reactants. You could only pick these 2 compounds to do it with. But if I said write a mole ratio only using the product, then you could only use these 2 to write. Or vice versa. It couldn't be those 2 because they're reactants. Right. Exactly. All right. So I want you very quickly to write 3 mole ratios of any type. I didn't limit you here. Pick 3 out of that equation. Now, did I balance it? No. You need to balance. And then I'm going to ask several of you to come to the board and write yours on the board.
You get to go to the board. That's my to-do.
Yeah, don't actually drop my pen and break it like the last one. What's wrong with basically someone teaches straight and one and so much? Alright, got three? Alright, you're pulling up there. Then decide to do.
I think it's, is this the marker?
Yes.
Oh, I'm on the camera. Oh, wait, let me grab that.
Don't push it. Where did you say that?
Oh, that's cool.
Now, you got the same problem Satori's just got. Look at your formula for F and look at your formula for C. Alright, look at what, because some of you, Satori did the exact same thing while I looked at her. Look at the formula for F, and look at the way Jordan wrote F. There's no two, yeah. So when you write those, do the formulas correctly. Alright. Go ahead, Touchdown.
Well, this pen is actually pretty heavy, and I thought it was.
It's the computer. If you drop it, the pens break. They're not, yes, we have shattered two. Come on.
You
We're not all day.
make one up on the bottom there. I mean, I haven't written down. Me and Emma are about the same height when I stand on the board.
Oh, that's awesome. Look how I did
You
that.
can use your
Look how
hand,
beautiful
too.
I did that. I know, I
It's
know.
like,
What? I love it.
it is like.
Oh, I know.
Ah.
I'm so excited. What the hell?
Oh, I want to go left.
No, Junior.
I'm trying to up it.
Oh, yeah. I do it all the time too. It's not that good. Oh, yeah.
Come on. It does not have to be perfect.
Y'all better not be wasting it.
Oh, that's cool. I like it. That's like that.
I'll be right back.
I can tell like some of them I did. Sure. All right. While I help Mr. Holt, write this down. For those of you who like titles, it's called mole conversion. Huh? What was what? The balance was 2525. All right, mole conversion. Now, you can skip the top two lines here. You don't have to write that. You need the equation and you need this question. So I'm gonna help Mr. Holt.
Oh, right here.
I mean, I don't I have to pack it up. No.
Oh, yeah, that's all good. I'm like 40 feet away.
You are not.
40. 40.
I'm 5'8". Huh?
All right, you have it? All right. Because I want to talk about how you decide what the mole ratio needs to be before you leave. You know, we're not just going to make up ratios for it for life.
That makes me laugh on me. I mean, I just do, but they just not. They just I don't know. It's just what level? I'm like on the floor sitting down.
All right, so if we have this equation, is it balanced? No. The lithium has how many?
I mean, one on the left.
That's up to you. That's really good break. All right, so 2 lithiums there, so we need 2 there. I have 2 O's and 2 O's, so that's how many?
4.
There's 3 plus 1, which is, so they're good. And then I have 2 H's and 2 H's, so they're good. And 1 C and 1 C, so the C's are good. All right, so, I'm going to make a mess. Put that 2 there. All right, so, just like always, I'm going to draw a what? T chart. All right, given data goes where? The top line. So I have 20 moles of what? Now it's important to label what you start with by compound. Now we're not just going to write moles. You need to write the compound. This is our given data. 20 moles of CO2. So I wrote moles of CO2 on the top line because now I have to keep track of what compound I have. Because remember, the conversion factor mole ratio is necessary to change the compound. So that means I'm going to do what? Whatever's on top has to go where? To the bottom, so we can do what? Cancel out. Now, we're going to ask ourselves one question. Are we changing compound? All right. If yes, put mole on top. Okay? So, look in your question up here. We're looking for how many moles of lithium hydroxide. Are we going to change compounds if we're looking for lithium hydroxide? What did they give us to start with? Carbon dioxide. It's carbon dioxide and lithium hydroxide, the same compound. No, they gave us 20 moles of CO2. They want us to go to lithium hydroxide. Are those the same compound? No. So are we changing compounds? The answer is yes, we are. Because we're changing compounds, we have to put moles on the top line. Because you see moles over moles, what's that called? What we just learned that was called today? That's called a mole ratio. Okay? This right here is called a mole ratio. Okay? So, what did we learn a mole ratio was for today? To change the compound. So we're going to change the compound here. Well, what compound do we want to put on the top? What did it ask us to go to? Lithium hydroxide. So look at your equation. Which of these is lithium hydroxide?
LiO2.
All right, that is carbonate for you. See how it's carbon? That's got carbonate. So that's not hydroxide. If you don't remember what hydroxide is off the top of your head, then look on your blue sheet. Okay? What's the formula for hydroxide? That's right, it's the OH. So if you're not sure, then look it up and find hydroxide. You know which one it is. All right, hydroxide is this one. Okay? And then you put LiOH on top. Now, a few minutes ago, we did mole ratios, right? Where did all of the numbers come from when you wrote all these mole ratios? That's right. So when we have moles over moles, and this is a mole ratio, where did all these numbers come from? They come from the coefficient. Huh? Compounds. So what's in front of lithium hydroxide? What's in front of CO2? So how are we going to calculate our answer? 20 times 2 is 40. I'm sorry. What's our homework tonight? Study for the test. The answers will be on the website. Now, those of you who want breakfast passes,